Good morning, students. So today we are going to start next portion of our 7th unit. In this portion we are going to study about nitric acid, allotropes of phosphorus, phosphine, and about halides of phosphorus. Okay. So first of all, how we can prepare nitric acid. So the lab method used for preparation of nitric acid is we have to react sodium nitrate with sulfuric acid, and there will be formation of nitric acid with sodium hydrogen sulfate. And if we want to prepare it on large scale, then ammonia is to be treated with oxygen, which will form nitric oxide. Okay, then nitric oxide will be made to undergo oxidation again, and then it will be converted into nitrogen dioxide. Okay, this nitrogen dioxide will be absorbed in water, and there will be formation of ammonia along with nitric oxide. Okay, then nitric oxide will again undergo this whole process. Okay, so this is the process. Now on large scale, which process we use and how we do it, this is briefly discussed over here. What we do, we take first of all ammonia, then we perform the process of oxidation, which results in the formation of nitric oxide, which again undergoes oxidation, and there is formation of nitrogen dioxide. It exists as dimer in the form of this. Now after absorption in water, there is formation of nitric acid, and along with this there is formation of NO also. Okay, now this NO formed is recycled, and the aqueous nitric acid can be concentrated by distillation up to 60% by mass. Okay, then we have to prepare when 98% of concentrated nitric acid, then again we have to perform the process of dehydration by using concentrated sulfuric acid. Concentrated sulfuric acid is a very good dehydrating agent. Okay, now when we prepare this nitric acid, then what are its properties? It is a colorless liquid. It has freezing point this much and boiling point this much. Okay, now when we talk about nitric acid which is used in laboratories, then that particular nitric acid contains 68% of nitric acid by mass, and it has specific gravity of 1.504. So you can remember this, that whatever nitric acid we are using in chemistry lab, that contains 68% of nitric acid by mass. Okay, and specific gravity is 1.504. Now in the gaseous state, nitric acid exists as a planar molecule. Nitric acid, what about its structure? So its structure is planar, or we say trigonal planar when we talk about gaseous state. So see, here it is. This OH bond is shown like this. Okay, and this, if you see, this is triangular planar form. Okay, this is triangular planar form. So this is attached with one of the oxygen atoms, and that atom with which it is attached, that oxygen atom has two lone pairs. Okay, see, these are two lone pairs. One electron is used for making bond with hydrogen, another is used for making bond with nitrogen. Okay, and the other oxygen atom where there is presence of two lone pairs, that oxygen is bonded with double bond to the nitrogen. Okay, and now since nitrogen makes 4 bonds, so it will carry positive charge. Okay, and that oxygen where single bond is present, that will be having more electron density, so that will be having negative charge. Okay, So this way we can represent the structure of nitric acid. Now, what are the properties of nitric acid? When we take dilute nitric acid and we react it with copper, it gives copper nitrate, cupric nitrate, along with the nitric oxide. And when we take it in concentrated form, then it again forms cupric nitrate, but there is formation of nitrogen dioxide. So if we want to prepare nitric oxide, then we have to use dilute nitric acid, and if we want to prepare nitrogen dioxide, then we have to use concentrated nitric acid. Okay. Now similarly, this nitric acid reacts with non-metals and metals as well. With non-metals, it will give carbon dioxide gas if it is reacting with carbon, and there will be formation of nitrogen dioxide. Similarly, with native metals, we say these are inactive metals or they are native metals. In the form of aqua regia, if we put gold in that, then it gets dissolved. There is formation of orochloric acid. There is formation of orochloric acid. Okay. So these are the reactions. These are some of the reactions of nitric acid. Now, how it reacts with hydrocarbons? With benzene, it forms nitrobenzene. Okay, nitric acid. But what we have to do? We have to take concentrated sulfuric acid also. Without concentrated sulfuric acid, it will not start. The reaction needs concentrated sulfuric acid along with nitric acid. Okay. Now similarly, when we take toluene and we react it with this, then there is formation of trinitrotoluene. We say it is TNT. Okay, this all we are going to discuss in organic chemistry. 2,4,6 trinitrotoluene. It is an explosive. Okay, it is used for making explosives. Similarly, with phenol, it gives 2,4,6 trinitrophenol. Okay, 2,4,6 trinitrophenol. Now see, when we take cane sugar, okay, then there is formation of oxalic acid along with water. Now see, here you don't confuse. This only means that nitric acid shows oxidizing agent character. It can oxidize sugar. Okay, it can oxidize sugar, and there will be formation of oxalic acid along with water. Okay, so this way it happens. This means that nitric acid has shown its oxidizing agent character. Okay, so don't confuse in this. Now there is a very important test which we are going to do in our practicals. This is called brown ring test. This test is for checking whether there is presence of nitrate ion or not in the given salt. Whichever salt is given to us, if we want to check the presence of nitrate ion, then this test is done. Now how we do it? Okay, now see, this test depends on ability of ferric ion, ferrous ion, Fe2 positive is ferrous, ability of ferrous ion to reduce nitrates into nitric oxide. Okay, so basic thing is that ferrous ions reduce nitrate ion into nitric oxide. Because of this capability, this test is possible. Okay, now what happens and how we go ahead in this test? Fe2 positive reacts with nitric oxide. It is going to react with nitric oxide, and there will be formation of brown colored complex. Now see, this test is usually carried out by adding dilute ferrous sulfate solution to an aqueous solution containing nitrate ion. Okay, see what we are going to do. We will take that salt in which nitrate ion is present. Okay, we will make its aqueous solution. Then we are going to add dilute ferrous sulfate solution in this. Okay, now what will happen when we have added dilute ferrous sulfate solution to salt containing nitrate ion? Then this ferrous ion will change nitrate ion into nitric oxide. Okay, now since we have added ferrous sulfate solution in excess, so this thing represents ferrous sulfate solution. Okay, hydrated ferrous ions, they will combine with nitric oxide and there will be formation of brown complex. This is the brown complex which will be formed. Okay, now how we can check it has been formed? Now see here in this picture, what we are going to do once we have added iron sulfate. Okay, see, we took this salt where nitrate ion was present, we added ferrous sulfate solution. Okay, then this thing happened, and now we are going to add an acid along the side of the test tube. Okay, we will drop down sulfuric acid along the side of the test tube, and then at the interface between the solution and sulfuric acid, see here, this was the solution down, and on this was the solution till here, and then we added sulfuric acid on that. Okay, and then at the interface we are able to see this is black circle form of thing. This is a ring and it is called brown ring. Okay, so if we are able to see this ring, then we will say that the given salt contains nitrate ion. Okay, now when we talk about allotropic forms of phosphorus, then there are three allotropic forms of phosphorus: white, red or black. Okay, white phosphorus is also known as yellow phosphorus. Okay, so let us discuss the different properties of white phosphorus first. It is a translucent white waxy solid. Okay, it is poisonous, it is insoluble in water but soluble in carbon disulfide. So see here what is to be remembered: carbon disulfide, CS2, carbon disulfide is a very good known polar solvent. It is a very good known polar solvent. Okay, so we can dissolve white phosphorus in CS2 solution. Okay, and it glows in dark. Now see, this phenomena of glowing in dark, this is known as chemiluminescence. Chemiluminescence means the phenomena of glowing a substance in dark is known as chemiluminescence. Okay, now it dissolves in boiling NaOH solution. If we take phosphorus and we put it in boiling sodium hydroxide solution in inert atmosphere, means air should not be there. Okay, otherwise in air it will react. Okay, so there should be inert atmosphere. Then what happens? There is formation of phosphine along with sodium hypophosphite. NaH2PO2 is called sodium hypophosphite. Okay, now as far as its structure is concerned, then it is just like the four atoms of phosphorus are arranged at the four corners of a regular tetrahedron. Okay, now there is bond angle of 60 degree between the p bond angle is 60 degree. Okay, now white phosphorus is less stable and is therefore more reactive. Okay, it is less stable, so it is most reactive. So it exists as P4 molecules and the bond angles are 60 degree. Okay, so how we can represent phosphorus? We will say that P4 represents white or yellow phosphorus. Okay, now one more thing, since it is highly reactive, so it catches fire in air. If we keep it in air, then it will catch fire. Okay, now let us come to second one. Second one is red phosphorus. Okay, red phosphorus is obtained by heating white phosphorus at 573 Kelvin in an inert atmosphere for several days. Means we have to heat for long in inert atmosphere, then we are going to get red phosphorus. Okay, now when red phosphorus is heated under high pressure, a series of phases of black phosphorus is formed. This is the third form. This is the third allotropic form of phosphorus. Okay, now red phosphorus possesses iron gray luster. Okay, it is having grayish iron gray luster. Okay, it is odorless, it is non-poisonous, and it is also insoluble in water. But okay, it is insoluble in water as well as in carbon disulfide. So red phosphorus is not soluble in carbon disulfide. Okay, now if we will see reactivity, then red phosphorus is very less reactive as compared to white phosphorus, and it does not show the phenomena of chemiluminescence. Chemiluminescence phenomena is not shown by red phosphorus. And as far as its structure is concerned, it is polymeric, means there is not only one P4 unit, there are more P4 units. It is polymeric, consists of chains of P4 tetrahedra linked together. Okay, so this is one P4, this is another P4, this is another P4. So these units are joined together, and so it forms red phosphorus. Okay, now as far as black phosphorus is concerned, then it exists in two forms, alpha black phosphorus and beta black phosphorus. What is alpha black phosphorus? It is formed when red phosphorus is heated in a sealed tube at 803 Kelvin. It can be sublimed in air, means in air it undergoes sublimation, and it has opaque monoclinic or rhombohedral crystals. So what is monoclinic and what is rhombohedral? This we have studied in solids types of crystals. Okay, now it does not oxidize in air, means when we will place it in air, it will sublimate, but it will not undergo oxidation. Okay, beta black phosphorus, as far as is concerned, it is prepared by heating white phosphorus at 473 Kelvin under high pressure, and it will not burn up to 673 Kelvin. Means if we are going to burn it so that its oxide is formed, then till 673 Kelvin it will remain as it is. Thereafter it will burn. Now see, here you can see the samples. This is white or yellow phosphorus, this is red phosphorus, and this is a sample of black phosphorus. As far as structure of black phosphorus is concerned, this is the structure of black phosphorus. It is just like hexagonal rings. Okay, now let us come to next thing, it is phosphine. Now how can we prepare phosphine? Phosphine can be prepared by using calcium phosphide. If we put calcium phosphide in water, then there is formation of phosphine. Or if we treat it with hydrochloric acid, then also there is formation of phosphine. As far as lab preparation is concerned, then what we have to do, we have to treat our yellow or white phosphorus with concentrated solution of boiling solution of sodium hydroxide. That will form phosphine, and sodium hypophosphite will also be formed. Okay, now if it is in pure form, then it is non-inflammable. Okay, if it is pure, then it will not burn, but if it is impure, then it will start burning. Okay, now impurity will be either of phosphorus vapors or of P2H4. So P2H4 is also formed along with PH3. Little bit amount of P2H4 will also be formed. So if we want to make it pure so that it does not undergo a burning process, what we do, we have to purify it. And how it is done? It is absorbed in hydroiodic acid to form phosphonium iodide, okay, which on treatment with KOH gives off phosphine. Okay, so what is done? We take this mixture PH4I, this is called phosphonium iodide, okay. Means how it is formed. First what we will do, we will take phosphine, we will add this hydroiodic acid, and there will be formation of phosphonium iodide, okay. Means we are going to purify our phosphine. So first we will react it with hydroiodic acid, there will be formation of phosphonium iodide, then phosphonium iodide will be treated with potassium hydroxide, and there will be formation of potassium iodide, water, and pure phosphine. So phosphine in pure form can be obtained like this. Now what are the different properties of phosphine? It is a colorless gas with rotten fish smell, and it is highly poisonous in nature. It explodes in contact with traces of oxidizing agents like nitric acid, chlorine, or bromine vapors. It is slightly soluble in water. The solution of phosphine in water decomposes in presence of light, giving red phosphorescent hydrogen. Okay, so these are different properties of phosphine. Now let us see how it reacts with other compounds. Okay, now see, phosphine when reacts with chlorine, it forms PCl5. When it reacts with copper sulfate, it gives cupric phosphide. It forms cupric phosphide. When it reacts with mercuric chloride, then it forms mercuric phosphide. Okay, and when it reacts with hydrobromic acid, then it forms phosphonium bromide. Just like ammonium bromide is there, there is formation of phosphonium bromide. Now what are the different uses of phosphine? Okay, now see, when we take phosphine and we produce smoke or mixture of air, mixture of fire and smoke, then that thing is known as Holme's signals. Okay, what do we know that? We call that as Holme's signals. Okay, so how that smoke and fire is obtained? Okay, now what we do, we take calcium carbide containers and calcium phosphide containers, and those containers are pierced. We make holes in those containers and then we throw it in the water. Let us suppose we are on a ship and we have to give another ship some danger signal. Then what we will do, we will take a calcium carbide and calcium phosphide containers, we will make holes in them and then we will throw it in the sea. Now what is going to happen? When these two compounds come in contact with water, there is formation of acetylene gas by calcium carbide and phosphine gas by calcium phosphide. Now those two gases start burning. At once when they are formed, there is production of smoke and they also start burning. So there is a formation of either smoke as well as there is formation of fire. So this thing acts as Holme's signal, or we say it is a smoke signal. It alerts the other ship. So phosphine has great importance in alarming the approaching ship from any danger. Okay, now let us come to phosphorus halides. Now there are two halides, one is PCl3 and another is PCl4. So first of all, how can we prepare it and what are its properties? For preparation of PCl3, we heat phosphorus with chlorine. Okay, and there is formation of PCl3. One more method is, if we heat phosphorus with the thionyl chloride, then also there is formation of phosphorus trichloride. Okay, now whichever way we prepare it, when we react it with water, there is formation of phosphorus acid. H3PO3 is phosphorus acid, and when it reacts with chlorine, it forms phosphorus pentachloride. When acetic acid reacts with phosphorus trichloride, then there is formation of acetyl chloride. Okay, with ethanol it forms chloroethane along with phosphoric acid. With silver cyanide it forms silver chloride, okay, along with cyanide of phosphorus. Okay, now similarly, how can we prepare PCl5? For preparing PCl5, either phosphorus is to be reacted with chlorine so that there is formation of PCl5, or phosphorus is to be reacted with thionyl chloride and it will form PCl5. So here concentrations of chlorine or thionyl chloride are varying. Rest reactions are same for the preparations of halides. Okay. Now when PCl5 reacts with water, it forms phosphorus oxychloride, and when it reacts with water, this phosphorus oxychloride, when it reacts with water, it forms phosphoric acid. Okay, now when we heat PCl5, it may produce PCl3 again. Similarly, PCl3 when reacts with ethanol, it forms chloroethane. When it reacts with acetic acid, it forms acetyl chloride. When it reacts with silver, it forms silver chloride. When it reacts with tin, it forms stannous chloride. Okay, so these two substances are reactive also in nature. Now let us compare their diagrams. PCl3 has pyramidal structure. See, it is just like NH3 structure. Okay, bond angles are different because of their sizes, but it is pyramidal in nature. And when we talk about PCl5, then it is trigonal bipyramidal. Okay, where 3 angles are of 120 and 2 angles are of 90 degree. Okay, so these are the topics which we discussed today. On the basis of that, you have to solve these home assignments. Okay, thank you.